Okay, everybody. So now it is time to talk about the phylum Annelida, which is the third of three phylums of worms that we're going to be learning about. This is also the most complex of the worm groups that we're going to learn about. And so you're going to start to become familiar with some of the different body systems and the different organ systems that this animal has that you'll see throughout the rest of the animal world that we'll talk about. Now, the phylum Annelida consists of what we call the segmented worms. And segments, and I'll say this many times, but these little round rings that you see that go the length of this body of this animal, these are called segments. So we say this is a segmented worm, or we say it is very segmented. And these things live all over the place. So they can live in fresh water, they can live in salt water, and they can also live in land. Most of us are familiar with this one right here, which is the earthworm, but there is so much more. Now, there's three classes of this phylum, and this is related to your exit ticket today, so pay attention. So there's class Oligochaeta, and that's the earthworms. You can also call them the oligochaetes. There is class Polychaeta, or the polychaetes. Those are all marine worms. And we'll have tomorrow in class for our creature feature, we're going to feature an animal from this particular class called a bobbit worm, which gives me nightmares. It's kind of a terrifying creature that lives in the ocean. And then another animal that gives me nightmares sometimes, and if you remind me, I'll tell you a story about it sometime, is the leeches, which is the class Hirudinae. Now, the term annelid means little rings, and it's talking about these segments, all these little rings that you can see in the body here. So each one of these little rings we call a segment. So this name refers to the many body segments that compose the body of a segmented worm. Now, there's a lot of different species in this phylum. There's 15,000 of them. But even though there's a lot, even though there's 15,000, they all share a few things in common. One, they are all bilaterally symmetric. So that means if you take an imaginary line and divide their body down the middle, then you'll have two equal halves. Okay, remember bi means two. They all are segmented, so they all have those little rings, that segmentation that I pointed out. They all have a true coelom, so we've been talking a lot about coelom. If you remember, the flatworms are acoelomates. They don't have a coelom. Anytime you add that letter A in front of a science word, it means not or not. And then the nematodes, the roundworms, were called pseudocoelomates, or fake or false coelomates. They actually have a coelom, but it's only partially lined with mesoderm tissue. This is the first true coelomate that we're going to study, which means they have a full coelom completely lined with mesoderm tissue. As do we, and as do all the other animals that we'll study from here on out have. So they also have three germ layers. All the worms have three germ layers. That's different than sponges and cnidarians. And just a reminder, those three germ layers are the endoderm, ectoderm, and mesoderm. Remember, the prefix endo means inside, the prefix ecto means outside, the prefix meso means middle. Now, the presence of a true coelom and also having these three germ layers allows the annelids to have the most complex body structure of all the worms, of all the three phylums that we've studied. And they're going to have all organ systems present. And if you need a reminder of what all those organ systems are, remember from the first quarter, you actually do have some guided notes on body systems that you can review if you forget what some of those things are. Now, there are advantages of having a true coelom. Now, if we're specific with annelids, the coelom of the annelids is partitioned, which means to be divided into little compartments. And what this does is it allows different parts of the body can expand or contract independently of one another. And that's good. That means like the animal can be moving and they can be digesting food at the same time and doing multiple activities. So it allows for more complexity and more complex behavior. Now, some other just like general characteristics of annelids is they have something called setae, which are these external bristles on the body. And that word bristle, if you don't know what that means, just think of like a little hair. Like if you use a brush, like a hairbrush, each one of those little pokey outy thingies is called a bristle. So these guys, and you might not know this, you might not think that they have bristles, like you've seen an earthworm before and they look kind of slimy. But if you look up really close, they have these external bristles on the body that they use for movement. Now, they can also have something called parapodia, which are like fleshy appendages, so fleshy things that stick out on each side of most of the body segments, like you can see in this animal here, which this is one of the marine worms, one of the polychaetes. Now, these characteristics, the setae and the parapodia, the number of setae and the presence or absence of parapodia, is how scientists distinguish between the three different classes of annelids. So it's what they use, those are the characteristics that scientists use to divide annelids into those three classes. Now, I'm just going to give a very quick overview of those three classes. And then we're going to look more specifically at the earthworm's anatomy next week. We're going to have some observations of earthworms too, some living earthworms. So the class Oligochaeta, which is the earthworms, annelids of this class, they generally live in soil or fresh water. They have no parapodia, so they don't have any of those fleshy appendages. And that word, Oligochaeta, means few bristles. So these worms have very few setae on each segment. So they do have them, but they just don't have as many as some of the other members of the phylum Annelida. And the most familiar, the most recognizable member of this class is the common earthworm that you guys are all know about. Now, the second class is called the class Polychaeta, or the polychaetes, and this is the class that the bobbit worm that we're going to talk about tomorrow belongs to, which are terrifying. About 2/3 of all annelids are polychaetes, and that term polychaete means many bristles, so opposite from the oligochaetes, the earthworms, which is few bristles. These guys have a lot, as you can see in this picture right here. And the bristles are these like hairy-like kind of structures that you can see all around. So this refers to the many setae that helps the polychaetes to move. Now, polychaetes differ. They're different from other worms in the fact that they have antennae, and they also have specialized mouth parts. Most of these guys are marine, so they live in the ocean. There are some free-swimming predators that use their strong jaws to feed on small animals. You'll see an example of that with the bobbit worm. The third and the last class is the Hirudinae, which is the leeches. And this is the smallest class of the annelids, and there's only about 300 different species of leeches. Most leeches live in the calm bodies of freshwater, and a few species can live on land. We do have leeches here in Utah, and leeches have no setae. Now, leeches are parasitic, and at the end of the leech's body is a sucker that can attach to surfaces. You can see it right here. So they suck the blood from other animals. And after they attach to the host, they secrete an anesthetic that prevents the host from feeling their presence. So they'll release that anesthetic so that they can bite and make a wound, and then they can just feed uninterrupted. Now, in addition to this anesthetic, they also secrete a substance that prevents the blood from clotting, so that the blood keeps flowing instead of forming a scab. And so that word secrete, we've had it before, but that word secrete just means to kind of leak out of the body, like your sweat. Your sweat secretes out of your body. And leeches still to this day actually have medicinal purposes. They still to this day will use leeches to suck out blood clots, that should say, from a wound, which will help promote circulation in that wound. And it can also be used to relieve pressure or joint, pressure in a joint, or a wound from permanently scarring. And so they use leeches to really increase the blood flow to an area so that healing can happen at a more rapid pace. And that's all I want to talk about with annelids today. Next time we're going to talk more specifically about their anatomy and their physiology so we can see how they work and how they're a little bit more complex than all the other animals that we've studied. That's it. Bye.